So today we are not only going to do stretching and compressing, we are going to do all of our transformations together. So the ones that we are adding are the stretches and compressions. Okay, so guys, it's our A, H, and K that tell us all of the transformations. So the A has a couple of jobs. The A value tells us which way the graph will open. Okay, whether it opens down or it opens up. Okay. It also tells us how wide or narrow it will be. And that's what we're specifically going to talk about today is the wide and narrow part. All right, what is the job for H?
It tells us how to shift up and down and left to right.
Two things. Okay, that's actually two jobs. There's like a little line here that didn't print. Okay, so which one tells us to shift sideways? Left and right.
H.
H. Okay, left or right. What about this one is the K? This one is up and down. Okay, now I made this beautiful number line for you so that you could see what happens as we change our A value. Okay, so yesterday we talked about only two possibilities really. We talked about what would happen if our A was +1 or -1. So when our A was +1, it was the same exact shape as the parent. It was just translated around, right? Shifted around. When we had an A value of -1, it was the same parent shape, but it was upside down like a frown, and we translated it around, right? Today, we are going to stretch and compress, and then move around and flip upside down and do all that stuff. So when our A value is positive, which way does the parabola open? Which way does the parabola open when A is positive? Yeah. Okay, what about when our A value is less than 0? Yeah. When A is negative, we open down. Thanks. Okay. Now, something special happens when A is between -1 and +1. Do you notice how in between -1 and +1, all of these little fractions have numerators that are smaller than the denominators? Okay, the values are getting closer and closer and closer to 0. Okay, this gives us our vertical compressions. So these same things in our linear unit gave us those really flat slopes where we had a lot more change in x and very small change in y. Okay, what do you think is going to happen if we multiply by a number like 2 or 3?
Vertically stretch.
Yeah, we're going to have our vertical stretch. Okay, so not only is it vertically stretched, but our A is positive, so it's going to open up like a cup and have really steep sides. When it's vertically vertically compressed and our A is positive, it'll open up like a cup, but it'll kind of look like flat, like a satellite dish. Okay, draw the pictures. Okay, what do you think happens when it's vertically compressed and when A is negative? It's squished and upside down. So it'll be like, here. Okay, over here, we get another vertical stretch. Okay, you can go in the hall. You can just go in the hall. When you're ready to be quiet and not distracting, you can come back. Easy. We'll see ya. All right, this is our vertical stretch. Okay, so not only is it stretched, but it's upside down. Any questions about that? Okay, so it gets steeper and steeper the farther we get from zero. As we come back to zero, it gets flatter and flatter and flatter. What do you think happens when we go to zero itself? Yeah, it's a totally flat horizontal line. Flat, not float. Flat. Okay, and it's neither positive nor negative, right? It's just zero. All right, let's graph this quadratic and see if we can figure out how to do it. Okay, let's start. We'll go from left to right with our A, H, and K. What is our A value here? The 2. So in front of the X is the 2, or an A value. So looking at our number line, specifically at yours because you can't see mine anymore, what do we know about it? Yeah, it's opening up and it's vertically stretched, so it's going to be like that. All right, what are our H and K?
Our H is 1 and our K is -5.
Okay, you're really close.
Positive
It was better the first time.
-5.
Okay, so the H is the one that lies. This one lies.
So it's -5.
Correct. Because the way that we get that +1 is by having minus a -1, right? Okay, so our vertex is at -1, -5. That's down here. Now, we're going to use our pattern to get a bunch of other points really, really quick. We're not going to do that whole thing with the table where we have to write all of our steps out. We're going to really quick do the pattern. So we'll have left or right, and then we'll have up. So if we go left or right 1, we go up 1, because 1 squared is 1. If we go left or right 2, we go up 4. Because if I square 2 or -2, I get 4. 3, 9. Now, do you all agree that I'm going to want to stretch by 2? How do you think I'm going to stretch and make this taller by 2? What am I going to multiply by? The ups or the sideways ones? Yeah, the ups. I'm going to multiply all my ups by 2. So instead of 1, I'm going to have 2. Instead of 4, I'll have 8. Instead of 9, I have 18. And now I can find my points really fast. So start at your vertex every time. Go left 1 up 2. Right 1 up 2. Left 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. I don't think we can fit 18 on here. So we're going to call it good. Oh, I messed up. Do your best. It doesn't have to be like perfect. Okay, we're going to take a tiny moment to talk about how these are awarded points on your test. Because I'll get some kids that'll like draw the vertex and then like draw a sketch and just kind of like throw a parabola on there without any precision. So your vertex is worth 1 point. These 4 other points are also worth a point. So if you just like throw a parabola on there because you looked at where it was on your calculator, you're going to miss a lot of points. You know what I mean? Because you're going to have to graph a lot of parabolas for me on this test. And if you do that every time, you're going to be hemorrhaging points. So please make sure you do the vertex and 4 accurate points. You guys can handle that. That's easy. So vertex and 4 more. It's just like your hand. Your thumb is your vertex, 4 more points like fingers. All right, compared. Oh, we need a min or max value statement. What does this graph have, a min or a max?
A min.
A min. So at what x value does the minimum happen?
-1.
Correct. At x equals -1, we have a min of, what is the lowest value? -5. So first you tell me where it happens, then you tell me how low it goes. Okay, so compared to our parent, the graph that we just made of h of x is wider, narrower, or the same? Narrower. We knew that from the beginning just by looking at our a value. Okay, now we get to do transformations. Did we do a rocks? No, we did not. No rocks because our graph opens up. Do we have a vertical stretch or compression? Okay, good. We have a vertical stretch by how much? Good. Vertical stretch by 2. All right, what about shifting? Okay, we shifted which way by 1? Left 1, down 5. Okay. Shifted left 1 and down 5 units. Remember, we can tell where the shift was by identifying the vertex. You don't have to look, you don't look at any other points other than the vertex to identify the shift. Okay, cool. Next one. Let's start with the a value again. What is our a value? Yeah, it's that -0.5. Good. So what does that tell us about our parabola? It's compressed. And what about the negative part?
Upside down.
Upside down. So it opens down and it's squished like a satellite dish. Okay, H is inside parentheses, K is outside at the end. So what is the H? 2, because it lies. What is the K? Good. Okay, so 2, 0. Now we need our pattern. So we've got our left or right and our ups. So 1 squared is 1, 2 squared is 4, 3 squared is 9. But we have a rocks and we have a compression. So what we're going to have to do is take our A value and multiply all of our ups by negative 0.5. So our ups are really going to turn into downs. You know what I mean? So negative 0.5 times 1, that gives us negative 0.5. Okay, what's half of 4, and then take the opposite? Negative 2, good. Okay, half of 9 and take the opposite. Negative 4.5, good. So we're going to have to graph some points that are not quite as pretty points. They're going to be in between the dots. So just do your best as you can. Start at the vertex. Go left 1 and down a half. It's going to be between the parallel horizontal grid lines. Okay, then go right 1 down a half. Left 2 down 2. Right 2 down 2. Left 3 down 4.5. Yes, 4.5. You can kind of use your symmetry of your parabola to make less counting work for yourself if you're sneaky about it. And then connect them, make them as smooth and pretty as possible. Don't forget your arrows on both ends. Okay, what about this one? Wider, narrower, or the same?
Wider.
Wider. And I forgot the min or max value statement, so let's go back. What do we have here, a min or a max?
We have a min.
No. We have a max, good recovery. Okay, so at x equals what? 2. We have a max of, what's the highest value that we get to? 0. You see how it doesn't go above 0?
Yeah.
Okay. So if you want, you can think about, okay, well, this is the surface of the ocean, right? And maybe this is the path of a little fish. Okay, and he's swimming along a parabolic path, nibbles on a little bit of algae at the top of his path at the surface, and then he dives back into the ocean. You can think of it like that if you want. Or not. All right, let's do the transformations. Do we have a rocks?
Yeah.
Yes. Okay, do we have a vertical stretch or compression? Okay. By how much?
5.5.
Good. Okay, and do we have a shift?
Yeah.
Good. Shifted right 2 units. Okay, questions? Okay, you guys are doing great. Okay. We had a problem like this yesterday, but we hadn't done all of our transformations yet. So now we've done them all. I want you to match these up as best you can. I think you can do it in like 2 or 3 minutes. You can talk to the people next to you, get them matched up. What did you say for x squared minus 5?
H.
H. It's shifted down. Correct. Okay, go to the right. Go to x squared plus 5. If minus 5 is down, what does plus 5 have to be?
Oh.
Up. So that one's C. All right, let's look at the next row. What if I put a 5 in front of x squared and make 5 the a value? Is that what happens to my graph?
It's narrower.
Correct. This is narrower, so it'll get skinny beanie. That's A. All right, what if I make my a value 0.5? It would be B. It gets wider. Oops. All right, what about if I add 5? It's like I'm putting a plus 5, but it's inside parentheses. It's actually a -5. You are correct because it's minus a negative. Those kind of ate each other. So which way does it go? Oh, your other right. Correct. Left. Okay, and then the one under it, this is the one that's right. What is that, F?
Yeah.
Sorry, guys, my board is being weird. Hold on, look away, look away. Don't stare at the sun. Okay. All right, what about this? What if I put a negative in front of my x squared? It's D, it's rocks. Reflection over the x-axis. Did anyone accidentally pick Roy? Anyone curious about the difference between rocks and Roy?
No.
A little bit? No? Nobody? Okay. I'm so glad you asked. This will take 2 seconds. It won't take long. So if I have a little heart up in my first quadrant and I reflect him over the x-axis, he pops down here. He's upside down. Okay? That's my rocks. Now if I do a Roy and I have my little heart up here in the first quadrant, he goes this way. This is Roy. So like the single ladies dance, that's a Roy. Right?
Is that offer still available for me to go in the hallway?
Yeah.
Okay.
All right, moving on. You guys just wait till you don't have me anymore and you get bored. Okay,
Can I
So-
take you for my geometry teacher?
you might get me. I have a geometry class.
You should pick me.
They don't let me pick. But if I could pick, I would pick you.
Don't pick me.
All right. So for this one, we have to put the functions in order from the widest graph, okay, to the narrowest. Okay. You may use the number line on the front to help you. So, which one is the widest with the smallest a value closest to 0? H. That's first. Okay, which one is next? G, correct. Followed by F. And last but not least, okay. Okay, which one of those puts them in order correctly? A. Oh, you guys are wizards. All right, we're going to do one more and then we're going to be done. Okay, which of the following is true? Yesterday we did false. Today we want true. When the graph of f of x equals x squared minus 7 gets transformed into the graph of g of x equals 5x squared minus 7. Maybe put those both in your calculator and see what happens. I'll do it too. I go to y equals. I put in x squared. Whoops, that was log. Oh,
Log.
x squared minus 7. And then I want 5x squared minus 7. And then I can go to my graph.
Something wrong with mine, right?
Is it yelling at you about window dimensions? Sorry, it was C. I forgot to pause the recording or I did something weird. I don't know what I did. Sorry.